Okay, so we're going to take it up to another level, a level that you haven't learned yet, but we're going to use stuff that you've already learned to be able to do these, and nothing really new is going to be added if we can just kind of do a little bit of thinking about the one step, and then the rest should come in handy. Now we're going to go right down to the questions. Now, these all can be done using the same method we learned before, but these ones work only because of one commonality between all three questions. Now, do you see anything? Because this is what you need to do. If you're going to really start to understand math, you've got to make your own generalizations. Now, do you see a good generalization of all three of those, how they are the same? Yes? Okay, good. The exponent, the second exponent must be half the size of the first exponent. Do you see that? Now you could say, well, it's just 2 more. Well, the third one isn't 2 more. But 3 is half of 6, 2 is half of 4, 2 half of 4. So that's the generalization that I need you to see. And this is how I've written it, so you can always check for it. But for what I'm going to teach you to be able to work, it must be in the form x to the n minus ax to the, not times 2, n over 2 plus c. And we're going to do these right now. We're just going to do these with ones in the front, okay, for these ones here. Now, what we're going to do is we'll just do like A and C maybe. Okay, so we'll do these two. Oh, what's going on here? Okay, so we'll do A and C. Okay, so we're going to do just like we've always done before. What two numbers add to give me -5, multiply to give me -14? First of all, what will be the signs? Negative and positive, very good. And those two numbers would be stereo over there. Okay, so now, remember we've always gone x minus 7, x plus 2. Well, x times x isn't going to equal a to the 4, is it? So you're still going to put this in the same. You're going to just have to think, what is that first number? Or first term. A squared. See, make sure that if you multiplied these two together, you would get a to the 4. So the book actually does it quite a complicated way, and like they do it in 1, 2, 3, 4, 5 steps. It takes them 5 steps because they do the substitution method. Now the substitution method, you can avoid 5 steps here if you can just do it like normal and then say, hey, I'll think about what the first term needs to be a to the 4th. So actually thinking takes away like 4 steps. Okay? Does it make sense that we'd pick a to the 2, not x? Okay? Now why did I say x? Because x is such a common one that we always use, right? But x times x, even if that was a squared, x times x wouldn't work, right? So we even have to think about it then. Okay? So the next one, let's do it. We got what two things add to -9, multiply to be positive 14. So what signs would I be looking for? 2 negatives, good. What would they be? 7, 2, 7, 2. So then it is -7, -2. Then you've just got to think about this right now. What times what equals x to the 6? X to the 3, x to the 3. Okay, and just for something to have on our study sheet, please put x to the 3 times x to the 3 does not equal x to the 9. Okay? Because that is the most common answer, common wrong answer that I will get for x to the 3 times x to the 3. Because remember that when you multiply powers, you add the exponents. Okay? So these are pretty quick and pretty easy if you will just do that one step without putting x's in there. Otherwise, I have to show you a substitution method, and you're into your 5 steps, right? And unfortunately, the more steps, the bigger chance you have of doing them wrong. Okay? So again, there's method 1, method 2. We're going to do them just the way we've always done them, but we're going to use thinking, and then we can do them just like we always did it before. So again, evaluate. Is the second one half the first one? By that I mean the exponent. Yes. So then we can do them. And we can do all of these on this page if you look, right? So let's do B. Actually, B's not any different than we did one last day. Let's do A, actually. We've done one like B. You guys know how to do that one. Okay. Now, this one here, this is a type 2. Now, why am I calling it a type 2? Because there's a value in front of the largest power. So then I'm doing what two things add to give me negative 5 and multiply to give me negative 24. Okay, now what would the signs be? Good, negative and a positive. Okay, those two numbers would be 8 and 3. Right, the 8 being the negative because it wins. So then I'll go 4x to the 4 minus 8 x squared plus 3x squared minus 6. So just make sure that those two are the sum of the one above it. Now, if that is true, then you're good to go, and we're going to save 5 steps again. Okay? Because this one we can do just by, now, same thing, put our brackets, and then take out common stuff. So from here on in, nothing's new. So I can take out a 4x squared, right? Leaving me with x squared minus 2. The next one I can take out a 3, leaving me with x squared minus 2. Then I have a common x squared minus 2 in both of them, leaving me with 4x squared plus 3. You didn't like that at first. Yeah, well, the reason why I always put this one first is because I'm actually taking it out. Okay? So truly, when I learned them, I always put the x squared minus 2 second. But if I really want to show factoring, well, I'm taking that out of both of them, so I should put it in the front. That's why I teach it that way. Okay. See, they're not going to be, today is going to be one of those days that you're just going to fly through the homework. Okay? I had a few people ask questions during the time, but most times people just flew through. Okay, let's do this one quick. Okay, now I can do it because it is half of the first one. So I'm looking for what two things add to be 10, what two things multiply to be negative 24. What are my powers? What are my signs? Sorry. Positive and a negative, because the positive will win since it's a positive 10. Okay, and they are 12 and 2, yeah. Now, but that's a good, 6 and 4, right? Those would have to be both positives to work. So if you do your signs first, you'll see why some things fail after. And that's why I do have to get you in the habit of thinking of your signs first, then fill in the numbers. And 6 and 4 coincidentally works, but the signs would have to be wrong. It would have to be a positive 24 for 6 and 4 to be legitimate, right? Okay, now we're just going to go and do 8x to the 4. And all you have to do is remember this part right here. It's got to equal this. So if I put 12x minus 2x, that doesn't equal 10x squared. But if I go 12x squared minus 2x squared minus 3, then I can do it just like normal after. So I had to think to do that step. I couldn't do the automatic XX, okay? And then I can take out a... What's the best I can take out of the first one? 4x squared. So that would be 2x squared plus 3. And the other one? No, all right. I could take out a 1 or a negative 1. But if I took out a 1, then I couldn't do the next step. So if I take out a negative 1, then I get 2x squared plus 3. And then 2x squared plus 3 times 4x squared minus 1. Okay? Does this make sense? Yes? Seriously, does it? Okay? Because this is wrong. If you gave it to me like this, it would be wrong. Can anyone see the error? Yep. Why? No. Because x squared times x squared is x to the 4. Okay, so if I asked you to factor the number 24, and this was on a test in grade 7 or whatever, and you wrote 2 times 12, is that correct? Why not? Huh? You can still go 2 times 4 times 3, is that correct? No, I can still go 2 times 2 times 2 times 3. Can I keep going with this? Is that a difference of squares? Yeah. Okay. So be careful on a test, especially all the written response. Did I go as far as I could? Okay. So this would be 2x squared plus 3. That's not going to go anywhere, but this would be 2x minus 1 and 2x plus 1. Okay, so that's a really good question to put on a written response because you guys know that I want each one of you to get 100, but I can't give it away, okay? You have to be a 100 student to get 100. So my 100 student will notice that. They'll look to see, have I gone far enough? Have I factored it all the way, right? So there's two things that should really be prominent on your study sheet. Number one, did I take out a common factor first? And at the end, did I go far enough? Okay? Because those two questions kind of have to be asked, or you're going to give up some marks and you're not going to be happy about it. Okay? Now, this one here is just on here because students kind of flip out when they're like, what? Sine x's? We never did sine x's. But you're going to do them just like you've always done them before. You could treat this as like 6x squared minus 7x plus 2. Same thing, okay? So this is a type 2. We're going, what do things add to give me negative 7 and multiply to give me 12? What would the signs be? 2 negatives. Okay, what would the numbers be? 4 and 3. Okay, so then you would just go 6 sine squared x minus 4 sine x minus 3 sine x plus 2. Okay, and again, make sure these are those. They do make that up, yeah. And then automatic, right? Put the brackets. Out of the first set, I can take out 2 sine x, right? Leave me with 3 sine x minus 2. And the second set, I want to take out a negative 1, because that would leave me with 3 sine x minus 2. So then I'm going to take a 3 sine x minus 2 out of both of them, and that leaves me with 2 sine x minus 1. So this one is just a reminder of just stay on the same course you've always done these for, and you'll be fine. Okay, now example 5 and 6, they're kind of in a category of all their own. Do you see how they have kind of a question inside of a question almost? See, if you wanted to do this the long way, you would have to FOIL out x minus 3, then multiply the 7 into all of them, and we still haven't even dealt with the negative 4 into all of those, then combine them all, and then go and factor them into their binomials. That way does work. It's just a lot of steps and a lot of work. So whenever you have, see, it's in the form 2, 1, right? And if these are the same, you see how they are the same? So if they're the same, you can just do a let statement. Let A, make it a big capital A, equal x minus 3. Now if you do that, if A equals x minus 3, then it would just be 7a squared minus 4a minus 3. It looks so scary after you do that one little thing. And what does A mean? X minus 3. Okay, they're synonyms. Okay, now let's go and just do this. So I'm looking for two things that add to give me negative 4 and multiply to give me negative 21. Now what would the signs be? Oh, negative, positive. What would be the numbers now? 7 and 3. So then I'd go 7a squared minus 7a plus 3a minus 3. And again, double check those two do make up negative 4a. After that, put my brackets, and in the first one I will take out 7a, leave me with a minus 1. The next one I'll take out a 3, positive 3, leaving me with a minus 1. See, again, it still works. I will get the same thing twice. So a minus 1 times 7a plus 3. Now, can I factor this anymore? Because always ask, do all the factoring first. Now that when you're done, then go backwards, and whatever you see a big A, put in x minus 3. Make sure you do it in brackets or you will get it wrong. So I'm just going to kind of keep the colors the same. A is x minus 3, and then minus 1, and then this is 7 x minus 3. Oops. I want to make this red too. Plus 3. Okay? So I started with the 7a squared minus 4a minus 3 after I did that. But now that I'm done the factoring, I can put that in. So then all you have to do now within the brackets is get the stuff together. So this would just be a minus 4, and this would be, Alex, can you do me a favor and just go next door quick and tell the person that's banging on the floor to... Now this would be 7x minus 21, right? Right? Yeah, but I'm going to do this. Just so I don't really skip that step. I'd lose too many people right now if I just put that down. Okay? So this is x minus 4, and this is 7x minus 18. Now these are a lot of work if you're going to go and FOIL this, then multiply the 7 into everything, multiply the negative 4 into everything, get it all together, and then after that, do all of the, still, you haven't even done any factoring yet. Okay? Just look over this quick, just so Alex has a chance to finish writing the rest. Now, just try and see if you can, I've given you one example, see if you can pull off B. Okay? See if you could pull off B right now. We'll do it together in about 2 minutes. So see if you can do B right beside it. Do a let statement. And, you know, for whatever you like. You can use like a, sometimes I've seen like the big X. But use the capital A, so if they use small lowercase a, you're not getting them mixed up, like B. Mm-hmm. Square root 4. Like, are you talking other ones as in A? Example 5A? I don't even know where we have an A minus 4. Yeah. Well, oh, no, because that would have to be x squared minus 4. Because they're not both perfect squares. X isn't a perfect square. Okay, so this one, what were my numbers? 10 and 9, yeah. Positive 10, negative 9. So 9a squared plus 10a minus 9a minus 10. Okay, then I can put in my brackets right away. The first set I can take out just an a with 9a plus 10. Okay, the next one I can just take out a negative 1, a plus 10, 9a plus 10 I should say. Okay, so 9a plus 10 times a minus 1. Okay, and I can't go any further with this. So now it's time to substitute a plus 4 in. Remember to do it with brackets. Okay, so that would be 9 times a plus 4 plus 10 and a plus 4 minus 1. So that would be 9a plus 36 plus 10 and a plus 3. 9a plus 46, a plus 3. Okay, so we're doing 1 to 5, all. Okay, not A, C, E, G, but 1 to 5. So instead of doing 6, 7, 8, 9, 10, just do 1 to 5.